Hello. Okay, so I'm going to record the third part of this video. So now this is a little bit tougher, not too much harder though. But what I'm gonna do, what I did here was graph this function log base 2 of x. So that was from the example from the first video, actually. So this is the graph of log base 2 of x, and here are a bunch of values in the table. Now some of these values cannot be seen, so like 3, 5, 6, but they're still on the curve. So I just took a few more data points just so you guys can kind of see this. Okay, so if you want to consider the following expressions here, if you want to consider the following expressions, we have log base 2 of 2 is going to be 1. Log base 2 of 4 is going to be 2. We have 8 here. Log base 2 of 8 is going to be 3. Okay. If we take the second example, we have log base 2 of 2 equals 1. Log base 2 of 5, which is 2.32. And we have log base 2 of 10 is going to be 3.322. Now, if some of you have started to see a pattern with this, you see this 2 here, and the 4, and the 8. 2 times 4 equals 8. Okay? If you see this one here, 2 times 5 equals 10. Okay? So, when you're applying the formula, or if you see a pattern here, if you look at all of these, no matter what you try, as long as these seem to work, the product property for logarithms is you just take the number in front here and then you can multiply them together. Okay. Now, I'll show you another example. So let's say we consider that same graph, and instead we take some other values. So let's say I do this one instead. So log base 2 of 6 is going to be 2.585, and you're subtracting log base 2 of 2. So it's going to be 1. So this is going to be log base 2 of 3, and this is 1.585. So 2.585 minus 1 is 1.585. Okay. If you take this one, log base 2 of 4, so log base 2 of 4 is going to be 2. Log base 2 of 1 is going to be 0. And it's going to equal log base 2 of 4. So 2 minus 0 is 2. So you can look at some of these patterns. I did a bunch of these so you can kind of see how that works. But if you guys noticed, if you see a subtraction, if you're subtracting logarithms, so 6 divided by 2 equals 3. And if you see here, 4 divided by 1 equals 4. Or in other words, the top one, 8 divided by 4 equals 2. Okay? Equals 2. So what you would see here is if you see you're subtracting logarithms, you would use this formula. Okay? So m and n here, so this would be m divided by n. If you see property where you're adding, it would be m times n. Okay? So let's try to do some examples here. Okay? So what we have here, I'm just going to copy this, so I don't need to copy it over and over. Okay, so it says consider the following examples. Condense the following examples into a single logarithm. Okay, so what I see here is, well, you have an addition symbol. 5 times 3 is 15. So this is log base x of 15. In other words, 5 times 3. So this is log base x of 15. Okay, and that's it. That's all there is to it. Okay, log base x of 20 plus log base x of 6. So same idea. So you take 20 times 6. 20 times 6. Okay, so what we have here is this is going to be log base x of 20 times 6. So this is going to be 120. Okay. Next one. So we have here log base x of 28 minus log base x of 4. So you have a subtraction symbol here. Since you have a subtraction symbol, this means you have to divide. Okay, so I'm going to copy this here because I'm going to need that. So this is log base x of 28 over 4. So this means log base x of 28 divided by 4 is going to be 7. Okay. All right. Next one. So log base x of 60 minus log base x of 5. Okay. Same idea. This is our base. Our base is x here. We're taking a top number, so 60. So 60. And we are dividing it. Ooh, what's going on? Okay, 60. We're dividing it by 5. So 60 divided by 5 is going to be 12. So we have, this is the same thing as log base x of 12. Okay, okay, a few more examples. Log base 3 of x plus log base 3 of 4x. So addition, again, means that you're multiplying. You're multiplying, okay? So I'm going to take the top example, so this one here. So I'm going to need that. Okay, so we have, oops, so, oh gosh, okay, log base 3. So log base 3 of x times 4x. Okay, so this is the same thing as of log base 3 of x times 4x. So x times x is x squared. So this is going to be 4x squared. And that is it. 4x squared. Okay. All right. So, and then there's 2 more examples here. So I'll go over those. So log base 4 of x to the 9th minus log base 4 of x to the 6th. So you would use this one because we're dealing with subtraction. We are dealing with subtraction here. So this is log base 4 of x raised to the, so this is x raised to the 9th power. And the one on the bottom is going to be x raised to the 6th power. Okay? So if you had to simplify this, x to the 9th divided by x to the 6th is basically, so it's going to be log, sorry, I'm going to just, being lazy. Okay, so this is going to be log base 4, and then you just take x to the 9th minus x to the 6th. So this is going to be x cubed. And that is your answer. Okay, last one. Okay, log base of 5 of 44 minus log base 5 of 11. Okay, so same idea. Okay, so I'm going to take this one, sorry. So what we know is our base is going to be 5. Our base is 5. M is 44. N is 11. Okay, so we just take that expression. We're just doing 44 divided by 11. So this means this is the same thing as log base 5 of 4. Okay, all right, and that is pretty much it to this one. Okay, so a little bit harder, not that much harder, but just let me know if you have any questions. So next video, what I'm going to do is I'm going to switch back to the like I'll show you paper instead. Okay, and then we'll just continue from there. All right, thanks.